part of today's class. We are looking at limit of a function today. That's what we are going to be looking at, the limit of a function. So we are going to be looking at the limit of a function. Now the question is, what is a limit? Now a limit is simply the value of an expression or a function as the variable here approaches a particular point. So the point here is 0. So as x approaches 0, what is the limit of this expression? Okay, as x approaches 0. So that's exactly what we'll be looking at in today's class. So the question now is, what we are simply going to do is to use this x, okay, replace it here, substitute for x here, then we get the value for the expression. So we are going to write the limiting function or the LT of this, all right, limiting function of x of this expression as cos x over x minus 2. So as x approaches 0, substitute here, we are now going to have the cosine of 0 divided by 0 minus 2. This is what we are going to get. We are simply going to substitute for x here. So the limiting function is simply the value of the function within that point, okay, within a particular point or point 0 here, but not necessarily at the point, but around the point we are considering. Here we are considering point 0. So the cosine of 0 is 1. Then underneath here, 0 minus 2 is minus 2. So this is the limit of this function as x approaches 0. Okay, it's not a difficult task. Okay, it's a very simple task. So just substitute what we have here. When we substitute it here, we are going to get what we're looking for. So for the very first question, the limit of cos x divided by x minus 2 is what? Is minus this. So we can go ahead to make it minus 1 over 2. So this is the best way to express this result. Okay, so this is what we have for question number 1. Thank you for joining me once more. Good morning and welcome to AZ Science TV. And this is a channel where we solve problems in mathematics and physics. But right now we are focusing much on mathematics. So today is the early morning show, although we are coming a little bit far late because it is a midterm break. So we believe that most students will be at home now. So we wanted to make sure that they are all awake and are able to join us. So if you are joining me and you are a student, please just let me know in the comment section that you are a student. If you are a teacher, please let me know. And if you have any reservation here or anything you want me to do here, please just let me know. All right, I'm more than ready to take your suggestions. So thank you very much for joining me. Now, for those of us that are joining now, let me repeat it. Please, if you have not subscribed, do it to smash the subscribe button. So here we are told to calculate the limiting function of this expression as x approaches 0. So x is the value that approaches this point. Okay, but what will be the behavior of this function or the value of this function around point 0? Okay, and that is exactly what limit talks about. All right, that's the explanation of the word limit. Now, the limiting function of the limiting value of this function as x approaches 0 is obtained by substituting the value of x at this point. Remember, x approaches 0. X is not equal to 0, all right? But we are going to substitute this 0 here to give us cos 0. Then here, same 0 will be here to give us 0 minus 2. So here, cos 0 is 1. The cosine of 0 is 1. While if we substitute here, we have 0 minus 2. Okay, 0 minus 2 is simply minus 2. So this gives us minus 1 over 2. So this is the answer to the question, to the first question this morning. Thank you very much for being here. So let's take the second question. Question number 2. So the second question, the second question says the second question is we should evaluate. So let us evaluate. The first one is calculate, where this one is evaluate. So they are the same. We evaluate limiting function, lim, lim, the limiting function of uh, s squared minus 16, s squared minus 16 divided by x plus 4, x plus 4 as x approaches 0, as x approaches 0. Now, there is something striking here that we need to be aware of as far as limit of a function is concerned. Please, I want you to give me much of your attention, okay? Now, this point here, this is x. Sorry, x is not x equal to 0, it's x approaches minus 4, right? X approaches minus 4. Now, we are having some challenges here. You will notice that if you substitute directly here, substitute minus 4 here, you are going to have 0 as the denominator. And this is not permitted in the limit of a function. So before we handle the limit of a function, before substituting this value, we have to make sure we reduce this to the lowest term. So we are going to reduce this fraction to the lowest term before doing our substitution. After cancelling out, okay, we have to cancel out, then after cancelling out, then we make our substitution and get our values. So the implication is that we are going to have, this is x squared, all right? This is x squared minus 16. X squared minus 16 divided by x plus 4, right? So here we have our lim as x tends to minus 4. Now this, we are going to change this to difference of two squares. If we change it to difference of two squares, we are going to have x squared, s squared minus 4 squared, and divided by x plus 4. So this is, we are going to factorize. We are factorizing the numerator. The denominator is already at its factor, okay, at the lowest factor. So this one, we have to factorize it. Then if we do that, we are going to have limiting function of x minus 4 and x as x tend to minus 4. So we are going to get this. Oh, okay, x. This is x squared, x plus 4. Then here we have x minus 4 divided by x plus 4. So this is the substitution we are going to make. We have been able to factorize the numerators. Now we can see that these two expressions are what? They are similar. So they are like terms. So what we do, let this and this go. So we are now left with what? Lim x minus 4 as x approaches minus 4. So this is what we have. You can see that we have reduced this limit now. We have reduced it to this level. So here we can now place our substitution. If we place our substitution here, we are going to have x is approaching minus 4. So we substitute for x, which is now minus 4, minus 4. Because in place of minus 4, because in place of x here, we have substituted minus 4. And if we evaluate it, we are going to get minus 8. So this is the answer to the second question for the class. So this question is quite simple as well, but we need to understand the concept we are dealing with, okay, with these questions. Now, the concept is this. When dealing with limit of a function, we must reduce the fraction. If it's a fraction, we must reduce it to the lowest term before substituting the given values. Okay, so here we have x squared minus 16 divided by x plus 4, and we are told to evaluate it, but we cannot just substitute this value here. If we make that changes, if we substitute these values here, you will discover that even here, if you substitute it, minus 4 square is 16. 16 minus 16 is 0. That may not give us a problem. But here, we have minus 4 plus 4. That will be 0. And it is wrong for us to have 0 at the denominator, or else it will give us a wrong answer. So the best thing to do is to express the numerator. Okay, not, you can see that the denominator has no problem. Okay, if there's need to express the denominator, we would have done that as well. Okay, we express it and factorize it. Here we want to do the same thing. So before factorizing this, we have to understand that this is difference of two squares. You can see that 16 is 4 square. Okay? Then difference of two squares is given like this. It's factorized in this manner, then divided by what we have at the denominator. Now we can see that we have a common factor here. So we strike the 2. What we'll do here is that we strike these 2. Then we are now left with x minus 4, which is now the x minus 4 we have here. So with this, we now have the freedom to substitute the value of x given in this question. So this is minus 4. So put in minus 4 here. We now have minus 4, minus 4. So that is what we have here, minus 4, minus 4. And this gives us minus 8. So this is the value we got for question number 2. And I do hope you are deriving value in my video. If you are joining me for the first time and you have not subscribed, please do well to smash the subscribe button so you can be a part of this family and grow with us. We'll be more than very happy to have you in our midst. Thank you very much for being here. Now, we are going to take the third question. If you have any question or suggestion or any comment at all, please put it in comment section and we'll be more than happy to have your comments. So let's go for the third question. The third question for today. So we're looking at limit. So we'll look at this, evaluate. Okay, let's look at this. We have to evaluate the limit of s square minus 4x plus 3. So lim s square minus 4x plus 3, sorry, not plus 8, plus 3 divided by s square minus 9 divided by s square minus 9. Okay. Then as x, okay, so we are not given here, as x approaches 3, as x approaches 3, as x approaches 3. So this is another question. Okay, this is another question. Now you can see here that we are having the same issue as we had in the previous question, in question number 2. You can see that if you substitute directly into this question, if you substitute 3 here, you have 3 square, which is 9. 9 minus 9 will give you 0. And that is not good for this question. So we have to factorize the numerator and also factorize the denominator. Once we achieve that, we'll go ahead and cancel out the common factors. Then we can do our substitution. So what we are going to do, we are going to rewrite the expression as x approaches 3. So here, x squared minus 9 squared we can express it as x squared minus 3 squared. Look at this, s squared minus 9. So this s squared minus 3 squared, because 3 squared will give us 9. Then for this, we are going to look for two numbers, just like we did in the live stream we did yesterday. We look for two numbers that will be multiplied to give us plus 3. Now, the one very beautiful thing about this, now let's look at this plus 3, okay, and this minus 4. This minus 4 and this plus 3. One very beautiful thing about this one is that this 3 here is a prime number. So only two numbers can be multiplied to give 3. Only two whole numbers, okay, because it's a prime number. And that number is 3 and 1. No other number can be multiplied to give 3, except fractions. But we don't deal with fractions here. What we did with here is whole numbers. So 3 and 1 is what we are going to get here. So we have 3 and 1, 3 and 1. Okay, please do well to watch my previous live streams when I upload them. Please, some of them are already uploaded. Watch it, you see how I got it. Even in my previous video, shortcut to factorization, you are going to get how I factorize this. Okay, so we have plus here. What is plus? Plus means that the two numbers, these two numbers must have the same sign. It does not mean that they must have plus. It can have plus and plus, or minus and minus. But how do I know what sign I'm going to put here? How do I know if here is going to be minus and minus or plus and plus? Then I will move to this place. You can see here, this is minus 4. So which means both of them are going to have minus and minus, because it's minus plus minus that will give us minus. All right, so don't forget that, because this is plus. Plus means that the two numbers must have the same sign. Then the minus here means that the two numbers must have minus, minus and minus. That is, these are the same signs they will have. Okay, both of them will have minus. So it means that here we are going to have minus and here minus. All right, that is the implication of 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 these two things, of these two values. So we are going to come here and create two brackets. Okay, just without wasting our time, we create two brackets and put the variable here, which is x. We put, look at the variable here is x. So we pick any of them. Let's pick minus 3 and put it here, and pick minus 1 and put it here. Right? So this is what we are going to pick and put here, since we have gotten what we are looking for. So we can let this one go now. We have gotten it. All right? Then we can simply go ahead and continue with our evaluation. We have the limiting function of x minus 3, x minus 3 in brackets, then here x minus 1, then divided by, this is difference of two squares. So just like in the previous question, when you have difference of two squares, just open two brackets, okay, then put x here, x plus 3 here, then here x minus 3. Okay, this is what we are going to get here, x plus 3 and x minus 3, because this is difference of two squares. Then here we have x approaching 3. But before we do our substitution, we can see that two brackets are similar here. They are alike. So what do? We cancel them. We cross them out. Okay? When we cross them out, we will now be left with the limiting function of x minus 1 divided by x plus 3 as x approaches 3. Now, this is what we are going to be left with after canceling this one. All right? Now, we have the freedom to substitute again. All right? We can substitute here, substitute for 3. So if we substitute for x here, so we are going to have, okay, this now becomes x, which is 3, because our x is 3 here, minus 1 divided by x again, which is 3, then plus 3, Okay. Then if we put this, our final answer is simply going to be 3 minus 3 minus 1 is 2, and 3 plus 3 is 6. All right. So we can reduce to the lowest term since 2 can divide 6. So we are going to use 2, okay, to divide 6. We are going to have 1 over 3. So this is the value for the answer. This is the answer for the third question for this morning. And I hope you understood this. All right. So if you are joining me for the first time, please, if you have not subscribed, do where to smash the subscribe button. All right. And you keep getting valuable content from AZ Science TV. We solve a lot of problems here almost every day, especially in the morning and in the evening. So do it to always join us. Even students, teachers, and anyone who loves maths can also be among us here. So thank you very much for being here. Now I'm going to repeat what I have said or what I said initially. Okay. So what I said here was that we are giving this expression to evaluate. Right? We do not simply go and do substitution. We have to check if this expression can be given a limit. All right? If it is what it's, but if we substitute this expression right now, we are going to get 3 square here will give us 9. 9 minus 9 will give us 0. And it is wrong to get 0 at the to have 0 at the numerator. That will make the expression meaningless. And limit of a function has a meaning. Okay? So it has a meaning. It determines the behavior of a function. It determines the value of a function. It determines whether a function will be continuous or non-continuous at a particular region. All right? So that's what the limit of a function actually does. And so we have to make sure that first of all, we find a way to reduce this expression. So that's what we have done here. We factorize the numerator, and we have to be sure that we also factorize the denominator if it's factorizable. So we can see that it is factorizable. So we factorize this numerator to give us this. All right. So to factorize any expression, please watch my previous videos on on the shortcut to factorize from here to here. Two-step factorization. Okay, no, there's no need going through the long step. Just follow the two-step. Okay, so I'm going to share the video in my next live stream so that you can see them. All right, as I'm uploading this video, I will share that video so that as you watch this one again, after I've uploaded it or after I've uploaded it, you also see the other videos so that you'll be able to tell how to factorize very quickly and very easily. All right. So here we express this a as a difference of two squares. Right. So this is what we'll get here. Then from here we transmit this one here. Just bring this one down here and change this one to this form. All right. We change it to this one. Sorry for the lights. It's coming on and off. I hope you are seeing the board clearly. Here you can see that we have been able to get something similar. Hmm? We have been able to see it to get something similar. So we can strike out this one. When we strike it out, this is the reason why the limit is not working. All right. So, but we have to strike it out using this one. So they are gone. We now have x minus 1 here, x minus 1, then divided by this value here, which is x plus 3. And right now, we can do our substitution, okay, without any trouble at all. So when we put our 3 here, we're going to have 3 minus 1. And when we put our 3 here, we'll have 3 plus 3, right? 3 minus 1 is 2, and 3 plus 3 is 6. And we know that this expression can be reduced further to its lowest term. So if we reduced it, we reduced it and we got 1 over 3. So this is exactly the answer to the second question. So thank you very much, and I hope you are following. Please, if there is any other suggestion you have, please put it in the comment section. This will help us to always improve on our content and continue to serve you better. So AZ Science TV is committed to serving you, okay? And students are preparing for exams. We are ready to assist you and make sure that you succeed in your examination. So let's go to the third question, the fourth question for this morning. Now we're going to pick the fourth question. The fourth question is that we should find the limit, the limit of this function. Find, we are told to find, okay, I'm going to make it smaller. We are told to find LT, LT of S square minus A square over X minus A. So this is what we are going to find. Okay, we are told to find this. So what will be the value of this expression? S squared minus A squared divided by S minus A as X approaches A. Now, you will also notice here that when you put A here, you're going to have A minus A, which is 0. And that is not good for this expression. Getting 0 at the denominator is not good for an expression. So what are we going to do? It's quite simple. So we write our X squared minus A squared divided by X squared minus A. All right, so the limiting function as X approaches A. So this is what we have here for the solution. What we are going to do here is to factorize. Okay, we're going to factorize this expression here. The numerator will be factorized. There's no need to factorize the denominator. It cannot be factorized. Okay, it's just this way. So if you factorize the numerator, we're going to have X plus A. Then here, we're going to have X minus A. Then all divided by X minus A, right? That's lim as X approaches A, right? This is what we are going to get. Now, we can see here that we have two brackets now that can cancel each other. Here we have X minus A, while here we also have X minus A. So we are now going to strike this. We strike this, okay? We strike these two brackets. Since they are equal, we strike them out. Then we are left with, we are now left with lim of the function as this. We are left with X plus A. So this is what we now have left after striking out this. We now have X plus A here. Now, it is easy for us to substitute. Let us go ahead and do our substitution. So what it means is that we substitute for X. X approaches A. So we are going to have A plus A. I hope we are following. We have A plus A. And we know that A plus A will give us 2A. So this is what we have for the fourth question. All right, always make sure you reduce to the lowest term and cancel what is here. Reduce what is here so that we do not get 0 at the denominator. If we get 0 at the denominator, it means the function is undefined. Remember, we did what we call defined and undefined function. A function is said to be undefined if the denominator is 0. And we do not use undefined function for the limit of a function. So we cannot use undefined function to get a limit. We have to make the function defined. So we change to defined function, okay, so that we can use to get our limits. So thank you very much. I hope it's understood. Let me still go over again. For those of us that are just joining now, I'll just please let's look at it again together. Now we are given the limiting function of x squared minus a squared divided by x minus a when x approaches a. Now, if you substitute this a here, we are going to get a minus a, which is 0. And it is wrong to have 0 here at the denominator. So the best thing to do is to factorize, is to remove this expression, okay? We want to cancel this expression. And we cannot do that except we factorize the numerator and get an expression that is similar to x minus a, so that we can use it to remove this expression or cancel it. So that was what we did here. We factorized this expression to get x plus a, then x minus a. Then we can cancel this one, okay? When we cancel this expression here, these two brackets, we are now left with x plus a. We are left with x plus a. I hope you are still seeing the board. The light went off, okay? We have x plus a. So I'm going to on it now, but I hope, let's just finish this. Then x plus a. Then we can substitute here. If we substitute, we are going to have a plus a here, which is now 2a. All right, so that's exactly what we have. Please permit me to switch on the lights. All right, so I hope we are following the expression. We are following the class. So this is for question number 4. So we are going to solve the 5th one, which will be the last one for today. So the question number 5, which is the very last one, we have to find the limit. Find the limit of, so question number 5. So we have to find lim, you can write as limiting function of, okay, this x approaches 0. So limiting function of s squared minus x, s squared minus x divided by x. All right, so this is s squared minus x, then divided by x. Same thing, if you substitute 0 here, the function will be meaningless and undefined. So we are going to have our x squared minus x over x as x approaches 0. As x approaches 0. So we are going to factorize this expression. We factorize the numerator. If we factorize the numerator, if we factorize the numerator, we are going to have LT, let's say, limiting function as x approaches 0. So if we factorize this, the highest common factor is x. Then we open brackets. We use the x to divide x squared. Okay, we use this x to divide x squared. We are left with only x inside the bracket. Then minus, we put minus here. Then we use this same x to divide this x. We are going to get 1 inside. Then we close our bracket and divide by this x that is at the denominator. Now you can see that we can strike out the x now, okay, which is making the function undefined. So we strike out this x. Now the function is defined. All right, we are now going to have we're going to have LT, limiting function of the expression x minus 1. So we now have x minus 1 here. We can then go ahead without any difficulty and factorize this expression. So if you factorize this expression, we substitute for 0, okay? So let's substitute, we have 0 minus 1, all right? Because x is 0, x is approaching 0. X is not 0, but x approaches 0. And finally, 0 minus 1 is minus 1. This is what we got. And this is the expression for, this is the value of this expression as x approaches 0. So thank you very much for being here. I hope you actually derive value. But before I go, let me still go over it again, so that for those of us who may have missed out this class, since it's an online class, some persons might be joining right now. Please, but if you are joining me right now and you have not subscribed, please do it to hit the subscribe button, okay? Now, we are told to find s squared minus x divided by x. we know that if we substitute this value of x here, we are going to get 0 at the denominator, and that makes the function undefined. And we do not use undefined functions to find the limit of a function. So we cannot use an undefined function. So we have to find a way to make the function defined. So this will help. How do we achieve this? We have to factorize this expression at the numerator. So when we factorize it, we got this. Okay, we got x, open bracket, x minus 1, then divided by x. So we can see that these two variables can cancel each other because they are same variable. So when they cancel, we are left with x minus 1 here. All right. Then we can now go ahead to substitute. When we substitute here, we're going to have 0 minus 1, which is 0 minus 1, because x approaches 0. So anyway you find x, just put 0 there. That gives us 0 minus 1. And 0 minus 1 is minus 1. So thank you very much for being a part of the class today. Yeah, please do well to join me in the evening, okay, at about 6, by 6 p.m., right? And do well to join me so that you can also be a part of this class. We are going to be dealing with another very interesting topic, and please do well not to miss out, okay? And if you have not subscribed, please hit or smash the subscribe button so that whenever I am coming on live, you will be notified. So I wish you a very wonderful day as we end the class. I appreciate you for your comments, and I thank you for your encouragement. You have been very wonderful. Your encouragement has kept us going. That's why we are where we are today. AZ Science TV is grateful to all of you, our subscribers, our viewers. Thank you very much, and I wish you the best for the rest of your day. Goodbye.